Hi, hello. Welcome to a ramble with me. Rambling today about November 2022, paper 1 from the department. Question 6.3. Let's go. Tavo plans to buy a car that costs 250,000 Rand. He will pay a deposit of 15% and take out a loan for the balance. So he's going to take out a loan for 85% of 250,000 Rand. The interest on the loan is 13% per annum, compounded monthly. Right. Calculate the value of the loan. So, like I said, because he's going to pay the 15% of the cost of the car up front, that means he only needs 85% of 250k to be loaned to him. And that we can get from our calculator. So that is 0.85 times 250,000. So that is 212.5 thousand. Right? So that's the value of the loan he is going to get. Request. Right. The first repayment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. Okay, so this is interesting because the loan is going to start growing from the moment it's granted, right? So the loan is, okay, the principal amount is that, and it is going to grow at a rate of 15%, not 15%, 13% per annum, compounded monthly. And it's going to grow for the 6 years that you're going to be repaying and the 6 months where you weren't repaying, right? So that's going to be, there are 72 months in 6 years plus the 6 months where you're not paying at all. So it's going to grow for a total of 78 months. Okay, so let's put that, or let's get that number into the calculator. 212,500 times 1 plus 78. Okay, so that is about 492,452. And then here we've got 3, 4, blah blah blah. Okay, I'm going to store that in case I'm definitely going to need it later. Right, and I'm going to remind myself that I have stored it. Okay, right, so that's the value. That's how much Tabo needs to repay. Okay, but now Tabo's repayments also in a way earn interest, right? So he's not going to repay this amount straight from his pocket, right? There's going to be the money that he's taking out and the interest that money accrues. So all of that altogether needs to amount to this. So we don't know how much he's going to have to pay every month. So let's let the monthly repayment be X. Okay, so these repayments are only gonna start 6 months after the loan has started, whatever. Okay, that's not really material. What we care about is the 6 years. So he's gonna have 6 years of monthly repayments, and yeah, okay, so let's just deal with that. So let's say he starts repaying at T0 and his last repayment will be at T7 1, right? Because T0 will be repayment number 1. In fact, it's probably confusing to start with T0 there, but anyway, T1 will be his second repayment, T2 will be his third repayment, and so you'll go, right? T69 is the third last repayment, T70 is the second last repayment, and T71 is the last and 72nd repayment, right? So 72 repayments in total. So yeah, if you've seen any of my finance videos from before, you know that these problems, the finance problems I like to look at in terms of geometric series. If you haven't seen my finance videos before, yeah, what I said. Right, so I genuinely do not know how the future value, present value formulae work. And that's funny because really, ultimately, they are based on geometric series. But yeah, I just prefer to work with the geometric series directly. If you prefer the formulae, amen, as long as you know what you're doing, happy days. If you don't know what you're doing, then even though this is a painful route to take, I recommend you take it instead, because what it's done for me is it gives me the confidence that I know what I'm doing. Okay, anyway, ramble aside, this last payment won't earn any interest. So it is just going to be X, right? The one before that will earn interest for a month. So that is X times 1 plus 0.13 divided by 12. And it just earns interest for 1 month. The one before that will earn interest for, yep, 2 months. Right? And so it will go, and so it will go until we have this guy who earns interest for the full duration of, you know, the 6 years. So he will earn interest for it's actually going to be 71 months. Yep. Right, so I said full duration of 6 years, but it's actually, you know, after 1 month, this guy will have earned interest for 1 month. After 2 months, he will have earned interest for, hey, wait, okay, I'm confusing myself. The first repayment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Yeah, so this is one of those situations where it's like, is it at the beginning? So like, say for example, the loan was granted on the 1st of June. Okay, so now, okay, when is the interest calculated? Okay, so I need to make an executive decision. So I feel like when you make your last payment, the loan closes. That repayment doesn't first sit for a month before the loan closes. So by that logic, then you know, hypothetically, who's this guy who's busy loaning here? Tabo will then, you know, let's say make a payment on the 1st of December. Okay, that will be his first repayment, and then it will earn interest at the end of December typically, and then on the 1st of January he'll make his next payment and it will earn interest at the end of January. Yeah, so I think I'm okay with how I've set up my timeline, right, where this guy is ultimately going to earn interest for 71 months. Yeah. Wait, I'm confusing myself. I am confusing myself. Okay, so let's just imagine they had said the loan will be repaid over a period of 1 year instead of 6. So what would have happened is at T0, Tabo would have made his first payment. And then at T1 would be his next payment. T2, so this is now 3 months, 4 months, 5 months, 6 months, 7 months, and then, so right now I'm saying that the timeline ends at 11, but that will be 11 months now. This duration will be 11 months. So actually it should be T12, 12. So then he's repaying over 12 months, which is actually then 13 payments. 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 13 Yeah, and I think it's the wording of this question that's weird, because so with a normal loan where there isn't a delay when delay before you start repaying it, what happens is that you get the loan here at T0, you start repaying it here. So it's a month, there's a built-in month delay. Okay, that's just confusing matters even worse. But yeah, in that situation, then when they say you are repaying over the course of a year, okay, I guess this is me contradicting myself, because in that situation, when they say you are repaying it over the course of a year, you still make 12 payments. So you stop here at T12, but this duration is actually 11 months. It's not a year. Um, oh, wow. Oh, okay. So this is also just me being a Mabena, because now I'm reading the question again. Oh, golly wolly, guys. Okay, so the English says the loan will be repaid over a period of 6 years after it has been granted. It gets granted here at T0. That's where it's granted. Okay, so I just need to, I'm not rewriting this, so I'm just going to move it down. Okay, so let's make this clear for Dami, because slow moments are real. Okay. And these ones, I'm going to need to move closer to each other. Honestly, I was suspicious of why they were so far apart. I was not happy with that deep down in my heart. Okay, I don't know if this is gonna... Ooh, interesting. But I did not want... Oh my goodness, what is happening in the world? Oh, guys. Everything that I do not want to happen is happening. Okay, so T71 is over there. T70 is here. T69 is here. Okay, and then right. Okay, so dot. Okay, so we are not repaying the loan here. Over here, loan is granted, right? Then the first repayment will be made 6 months after the loan was granted, so that will be over here. Okay, right, so here we are not repaying yet. Okay, so we've got 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. This is where we make our first repayment. Okay, cool. And they said the loan will be repaid over a period of 6 years after it has been granted. Okay, so now my confusion of where the timeline ends is cleared up, because the timeline will end at T72, right? Because that will be 6 years since the loan was granted, and I think it makes sense to speak about everything relative to when the loan is granted. Right. So how long is the payments going on? Well, it's going to be, so if he had started here, it would be 72 in total, but he is skipping out on 1, 2, 3, 4, 5 of them. So it's going to actually be 72 minus 5, 67 payments in total. Okay, so now for what I was trying to achieve down here, right? So yeah, pretty much like what I said before, this last one will not earn interest. Once you make this last repayment, your loan account closes. The one before that will earn interest for a month. The one before that will earn interest for 2 months, right? And then the interesting one is, okay, this one over here, how much interest is that one going to bear? And so from T6 to T7 is 1 month, to T8 is 2 months. Okay, so I must just say 72 minus 6, which is 66. So it's going to chill and bear interest for 66 months. Right, and just to do a sanity check, if it had been paid here, then it would have earned interest for 71 months, right? If it had been made here, for example, hypothetically, it would have earned interest for 72 months, for the full 72 months. So okay, so let's deal with this as a starting point. So if it was here, it would have been 72 months, but now it's not here, it's here. So that means it's missing out on 1, 2, 3, 4, 5, 6. So 72 minus 6. I hope that makes sense. Yeah, sometimes trying to explain what's going on in my brain is a bit weird. Anyway, so all of this, all right, all of these repayments, wow. Yeah. We need all of those repayments to add up to that loan amount and all the interest that it is going to accrue, right? So it needs to add up to this amount that we calculated here. Okay, and of course then this is a geometric series, right? With a equal to x, with r equal to 1 plus 0,13 over 12. That's what we're timesing each term with each time. The number of terms in the series, well, there's 67 of them, right? Yeah, because we've got a 1, 2, 3, 4, 5, 6 up until 66, and this one, this term that doesn't have this little bit to it. So that's 67 terms in total. And we are trying to, therefore we're trying to work out the value of S67. Well, no, we know the value of S67. The value of S67 is this, right? We want the 67 terms to add up to this guy. We want to find which x value will make that happen. So let's set up our equation. So geometric series goes like this. Okay, so we have our sum value, right? And then our a is unknown, our r is this, our n is 67, and then down here we have the r again, minus 1. So these guys will cancel out. Okay. Right, so now we want to figure out the value of x that will make this equation true. So I mean, just bear in mind that this is the same as x times this massive number. Right? Okay, because if you put that over 1, then the x will come back here and the 1 will just leave this unchanged. Right, so the reason why I'm pointing that out is because we can then work out what this number is, okay, which I'm going to do. Okay, so that is then x times 97,69, blah blah blah. Okay, and that has to be equal to 492,452,34, blah blah blah. And so to get x by itself, I'm going to divide both sides by this number, right? So x will be equal to 492,452,34 divided by 97,698 blah blah blah. Right, and this number we stored in, no, don't store it. Okay, we stored in A, and the oh, what have I done? Oh no, oh boy. Okay, right, I need to work out my fancy number again. Oh wait, surely it's here. So, oh, I've deleted my history. Okay, right. Have my number. Right, so X will be about 5,040 Rand and 52 cents. Okay, let's see if the memo is loving on me. So first of all, we agree about the first question. The loan value, the principal amount is 212,500 Rand. As for the second bit, we do not agree. So they have a different answer to me. So let me try and see. So yeah, these things, the interpretation is so important. So what they've done is they have taken this loan amount, ne? And they've grown it for 5 months. So for me, that is okay. So this is where the loan is granted. So if it grows for 5 months, 1, 2, 3, 4, that puts us here, right? So they figured out that at this point, the value of the loan will be 224,000 Rand and some cents. And then they try to figure out what repayments Thabo will need to make in order for the repayments to cover this amount. But I feel like if Thabo is only starting repayments here, the loan has grown by another month at this point. So the repayments have to take that bit of interest into account as well. So in as much as we've gotten different answers, I am inclined to disagree with the rationale for this answer. And yeah, if there are any maths teachers checking out my content, thank you, first and foremost. But secondly, could you please just comment on my reasoning, and if you think the memo is in fact correct, yeah, maybe explain to me how the present value formula works, because that's what's been used over here. But yeah, I'm not convinced. I am not convinced by this answer that has been provided. Yeah, because I'm just thinking, I'm thinking here. Okay, let's just test their answer. So their answer is 4724,96. So we are saying that this loan, the 212,500, is going to grow for 6 years at 13% per annum, compounded monthly, right? So that is going to take us to, okay, calculator come through. So that will be 212,500 times 1 plus 0.13 over 12 for 6 times 12, right? So that's gonna, in total, the loan will grow to this much, right? And then this guy over here, Thabo's going to make 67 of these deposits, okay? And they're also going to grow under these conditions. So let's see what that will come to. So that will be a geometric series where the very last deposit won't grow at all, so that will be our A. Then the common ratio will be this, right? And how many terms will we, oh my goodness, what is happening in the world? Go back to where you were. Sorry about that. Okay. Right, and there are 67 terms in the series. And then, okay, down here we'll just end up with this. And that ends up being 461,622,15, which is indeed very close. Let me double check my answer. So my answer, I got 5040.52. Let's see. 5040, oopsie, 5040.52. So I get a dramatically bigger number. So my answer is definitely off. This answer from the memo is definitely on like a scone. So let me try to figure out where I went wrong. Okay, so my rationale was, oh, oops. Oh, I've got problems. This is not good. Okay. This was still based. Oh, I got that number. Oh, I updated the timeline and I forgot to update this number. Okay, so this loan is not going for 78 months. We established that it's going for 72. The trauma of it all. Okay, I'm going to make my corrections in a different color. And I think we should then still arrive at the same answer as the memo. Okay, so this is actually to the power of 72, not 78. Oh, golly molly. Okay, so Kalki, come out, wherever you are. So this is 212,500. This is a number we worked out on the other page, but this is... come on, dummy. Okay, this is officially my last video for the night because no, I'm not going to. I think I'll probably do one more video in the hopes of it going better than this one has. Okay, so this is 461,622,40 whatever. Let me store that. Okay. 40 blah blah blah. Okay, so yeah, I think that this is where we have gone wrong, comrades. 461,622,40 blah blah blah. Then I still stand by the numbers for the geometric series. Right, and I mean, this is, so once you divide this by this, you'll actually see that this is the present value formula in disguise. This is where the present formula comes from. Anyway, so now 461,622,40 461,622,40 blah blah blah. Okay, so now I want to work out this number again. Should have told you, my brother. So that is 1 plus 0.1. Oh, guys, what is going on right now? How did I get to this menu and how do I get rid of it? Okay, interesting. Okay, right, so this is to the power of 67 minus 1, and then down here we have 0.13 over 12. Okay, so I'm going to store you just for good measure, just in case I've gotten this wrong a second time now. So now we're going to see that guy divided by this guy, and we get 4724.96. Okay, excitement took over. We get the correct answer. Sorry memo. Okay, so clearly, yeah, I definitely do not understand how to use the present value formula. Well, I guess the logic with the present value formula is whatever the loan is at your T0, which they now move to be here, you can then apply the present value formula to figure out the repayments, assuming that they are made 1 month after the loan started. So I guess that is just kind of how the present value formula works. So that's why they didn't work out what the value of the loan is here. It always has to be 1 month before the repayment start. Okay, this is me grasping. Okay, cool. But yeah, excited that we did get to the same answer. Sorry, memo. I messed up. I did mess up there. But yeah, as usual, always fruitful to figure out where the messes are. That should have been my first port of call, honestly, before thinking the memo was wrong. My bad. Anyway, thanks for sticking around. Always a joy to see that people are engaging with these rambles and hopefully finding value in them. Cool. See you another time for another ramble.